Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios. And today I want to talk about a topic that is very interesting to me, and that topic is type safety. Do we actually need type safety or not? Is it something that we just got used to from the various programming languages that use type safety? What types of type safety are there? And so I think this is a very interesting topic, and it's been fascinating to me since I started writing code in a specific style. And let me just show you what this style is. This is from a longer thread on Mastodon that I will refer to in the rest of the video. And basically the style of programming that I've been practicing for a while now, is for a few years actually, is a kind of style of programming where I don't define types for methods, parameters, data members, variables, unless I have to, right? So this means is that every method, every function will just have the names of the parameters, not the types themselves, and every class will have the names of the members but not their types. This also comes with continuous validation at the entry of the system. So basically, if it's a web application, at the entry, at the input, typically you'll have a controller, and the controller will grab the data. But the first thing I do is pass the data to validators. And the validators are very specific to the various types that I'm looking for. And then once I'm getting there, usually a lot of that data will turn into objects, into value objects that are passed around to other types of classes like services, or classes that actually do some work. And so there's a lot of validation at the entry of the system. This is important for two reasons. One is to prevent bugs, like things that are different types and that I'm passing around. But I think most importantly, it's actually to prevent security issues. For security, we need to validate everything that enters our system, and so a lot of these things need to be validated at input. And then, as I say, I define my own objects and use them with duck typing. And if you're not familiar with duck typing, what it means is that if it looks like a duck and if it works like a duck, then it is a duck. But fundamentally, how it works in practice is, let's say you have an object A, and you don't know what type it is because you got it as a parameter in the method. You have no idea of the type, and you call a.do something. If that object has the do something method, then everything will be fine. It looks like a duck, it works like a duck, it has that method with parameters, it's called, and it might give you a runtime error in case you don't have the right, are not passing the right parameters and so on. But it will work, and it will work without any issues. One thing that happens due to this style is that when you look at the method, you only have the names, you don't have the types, you only have the parameter names. And then you it pushes you towards naming parameters precisely and towards limiting the number of parameters. I've had this situation often when I kept adding more and more parameters because it was convenient, but then I realized, oh, I actually need to group those into one thing and start calling them from an object and passing an object instead of passing, or maybe a value type would be better said. Sometimes an object that also has values and methods. So this is something very interesting. And now what happened is that we tried this style on a product called Eventrix that we were developing a few years ago. And back then we were developing in Groovy, Groovy on Rails. So not Ruby on Rails, but Groovy on Rails. It's a kind of a similar language, but that is running on JVM. And it's a language that I actually like. But I haven't used it in a while. I kind of switched to Python for the newer things that I'm developing. And what I expected was that we'll have to write more tests. We would write tests anyway, but I expected that we would need to write more tests for this thing to work. And I expected that we might get into some troubles. Well, guess what? We didn't have to write more tests. And the only trouble we got into was when we were using names that were clashing with some predefined names. So in case you don't know, for example, if you in Groovy, okay, it's using some Spring magic. So it injects a few methods on controllers, on things like that, adds them at runtime. And if you were colliding with those methods, then you got into trouble. But this only happened like once or twice in a couple of years. And when it happened, we knew that when anything weird happens, it's probably due to that. And we fixed it very quickly. Now, why do I prefer this style of programming? First of all, it's not for every type of programming, and I will explain it. I explain in a moment why I think that. But it's very useful for things that change a lot. And I think when you think about a web application, which is what we are developing, what you have is that the input and the output are more constrained, in the sense that at the input you'll get some values. Okay, you'll need to change things, maybe add a new controller, add a new parameter to the controller, add a new validation, things like that. But you'll also need, on the other end, if you're using a relational database, you'll need to make sure that you are passing in the correct type into the database. Although I would say this is mostly a problem in Java because of the ORMs that you use there. If you're not using an ORM, then most likely you can write your own queries. That's another story, something that can help you if you are following patterns like hexagonal architecture or clean architecture. Then you might be inclined to writing your own queries, and then those queries can take into account typically what values you get, no matter their type. But what's interesting is that you want a lot of flexibility between the input and the output. So inside this system, What I really want is I want to be able to move things around. I want to be able to regroup things. I want to be able to do all kind of stuff. And I find that using this style of programming actually helped me make things more flexible. And don't think about types, but rather think about objects that I'm passing around. And this was the style description. Now, this gives us a few interesting things. So, for example, you can pass on different objects of different types as parameters as long as they have the correct function, signature, and so on. So basically the only constraint that you have on an object is to have a specific function that is used in that particular object that you are passing it into. And now the question is whether this gets you into trouble. I like this style because it allows us more flexibility. But could it get us into trouble? Well, it didn't get us into trouble, interestingly enough. And I think maybe part of it is because we used very small objects, and also because, as what I said, everything goes into names. You have very precise names, very clear names, and that tell you whether something is working, whether you are passing in the right parameters or not. So just let me show you a quick example of something that I'm working on now. This is actually an open source. Actually, I think it's a public repository right now. I hope it is, but if it's not, anyway, the idea is to make it open source. So what we're trying to do here is to start from a template and generate a number of files. So you have a template, you have, let's say, a CSV file, or it can be any kind of list. And with the list and the template, you generate a number of files. This is something that we need for a lot of things, and it's quite useful. So the crux of it is here. Like, this is one of the classes that I'm using, transform process. I'm still not very happy with the names. I want to improve the names a bit more. But even so, if I'm going here, I see, okay, we have a reader, we have a row template, we have common values, a writer, and a progress display. And this gives me enough information. Once you know what this is trying to do and kind of how it's structured, you can already see on the left side that you have a bunch of writers. You have a console writer, a file writer, and a multi-writer. So these are what you would pass in as a writer. A row template, you have a row template.py, so you already have a class row template. For reader, you have a table reader from CSV. But you might have table reader from Excel, or table reader from any kind of table, or from an API or something like that. And you have a progress display, which is something that shows the progress. This is, once again, there's a class progress display. Right, so we have progress display here, we have row template, we have multi-writer. So all these things are already defined for us. And you can, once you name them correctly, then you can actually pass them. So here you don't have any types. I could define types, but I don't have any. And then there's a transform that is called on this, and it does a bunch of things here. Yeah, I have a commented line because I was working on something. So this is how this code looks like, and maybe let's look at another part of the code, like row template. Now in row template, this is interesting. This is a data class. So a data class is what I think of as roughly a value object. Only in this case it's actually rendering, so maybe it's not such is not that good a name. But the basic idea is that it gets some values. It has a name template because you need a name for the resulting file. You have a content template, which is what you'll have inside the file. You render it. And here, yes, here I specified the types. But as you can see, I'm only specifying the types when I need them. And to be honest, I'm not really sure I need them here. I specify them because of the data class thing, but probably it would work without having a template. Because basically what I need is something that has render of values. This is all. This is all I need, nothing more. So, and it's already in the name of the variable that it's a template. So whatever you think is a template in your context will work. So now this is very interesting, because to me what this does fundamentally is you use a specific type of object. Let me go back to the process, transform process. So if I'm looking here, I see a progress display needs a progress. Probably it would be advanced or progress, yeah. And then I have a render and so on. So basically what you have here is defining constraints for the objects that you are working with that are very loose constraints. It's a very loose kind of coupling. The loose constraint is that it has to have a render that receives a list or a collection, basically. It doesn't even have to be a list. Anything that can be iterated upon. Do I care what is in there? Well, I think here is actually dictionary, right? Because it's like name and value, name and value. So it's something that resembles a dictionary. Do I care what it is? Not really. Do I care what render does? Well, as long as it doesn't fail, you know, not really. So what would this mean is that, for example, if I want to change the dictionary type here with something else, the only thing that I need to have is something that resembles a dictionary. So the only things that I'm using out of a dictionary are the pipe, which is join, basically an operation to join the two dictionaries, and access by, you know, the keys, and based on a key access the values, or actually access the key and the value. That's it. This is all I need. So I can switch to another collection very easily. Similarly, if I want my progress display to be different, okay, I can implement another type of progress display, maybe something that returns, sends an email, let's say, at the end instead of displaying at the console. Pass it in when it progresses, and so on. So these are elements that are very loosely coupled. And actually, one thing that I would really like and that I'm missing here is that when I first define this, I should be able to say somewhere, in this case, where I'm defining this is in the, I think it's in run from args. Run from args. Still a work in progress. I'm still not very happy with it, but need to work on it a bit more. Basically, what I would like to have is to say, okay, when I'm creating all of this stuff, just be careful that mapping needs to have the access, the key and value thing. Reader needs to have a read method, and so on. I'd like to have this in the language, kind of a specifier for the types that I'm using. But I would really like to have this centralized somewhere and say, okay, these are my expectations for these types. Because I think often we are think of it kind of like permissions. Like you are allowing your code to access the key and value from that variable. I'm allowing my code to access the read method from that variable. And in this process, I'm also checking whether that exists or not. So this would be my thinking about this type of code. And I find it very, very interesting that we didn't get in trouble with it. We didn't have to write more tests. We didn't have more errors. We didn't have more issues. Everything was fairly well. And so I was always wondering, ever since then, I kept wondering, okay, so what about the type safety? Is type safety something that I'm missing, that I misunderstand? And so I asked this question, when you think about type safety, what do you think about? And I got a few good answers. Compilers, tools, runtime validations. From Marcus Stecker. And I think runtime validation, well, we have a few trade-offs here with this style of programming. One of them is that I have increased work when refactoring and performance. Performance will be slightly lower because on every call, the system, the language needs to find a method to call, and it's slightly less efficient than compiling it. Now there are ways to dealing with that, and some languages do deal with this in various other ways. And refactoring will get a bit slower because you don't have, at least the tools are not smart enough to deal with these kinds of things. Actually, what I would say is that tools are not adapted to this style of programming. Refactoring tools try to catch everything from every possibility. And when you are dealing with dynamic types, they are having troubles figuring out what type it is. Now, the thing is, I'm calling these hidden types, or I ended up calling them hidden types, because if you know anything about Python or about Groovy, there's actually a type behind all this, right? So it's not that the object doesn't have a type that I'm passing in, it's just that I don't care about the type. I don't write it down. But the object itself, of course, it has a type behind the scenes. I just don't care about what the type is. And so another answer was that maybe I'm missing the team from some year, members coming and going over time. I more or less, I wonder about that. So I think that if you have the names well represented, and if you define your design patterns that you are using, then anybody can get into this style of programming fairly quickly. But indeed, you need to put in the actual design work of figuring out what design patterns you are using and how you are using them, how they are called, how they are named in your code, and what is their role. And I think this is just enough, along with the actual understanding of the domain that you are working in, to make this work. And then I got a very interesting answer from Sleepy Fox. The data show that types offer no benefits in terms of defect injection rate, which is in line with my experience. So the reality is that some people think better with types and some without. It really is a personal and team preference. Very interesting. Now, this conversation got into other things like guardrails and so on. But I think, let me go to another answer from Marcus, which is more specific. And this is, in JavaScript, using types removes an entire category of errors. Access on variables that are undefined, that may not even be possible in other languages. Now, could you try to access variables that are undefined in Python? If a variable doesn't exist, you'll probably catch it when writing tests. Now, a variable that is initialized or that is defined, well, I'm not sure what undefined means in JavaScript because there are so many different situations. You can have in Python things like, and I had some of the problems with passing a variable and I got not a number because it was a string or something like that. All right. But you get not a number, that is something that is initialized and so on. So I'm actually not sure how this is happening in JavaScript. This is maybe one of the reasons, now thinking back, thinking retroactively, while even though I try to stay impartial to programming languages, and I will write code in any programming language you want me to, well, any modern one, perhaps not COBOL and Fortran other than for having fun. But with JavaScript, I have a bit of a problem, a personal dislike. I tend not to like the way JavaScript code is structured. I think it has too many, well, if you want to write classes, to use prototypes. So the object style of JavaScript, it's a bit weird. The syntax is weird and so on. With this being said, I will write code in JavaScript without a problem, but it's not my first choice when I can avoid it. So there seems to be a JavaScript specific problem. The second thing that he said is that it makes refactoring harder and accidental property swaps more likely. Yeah, so I think refactoring harder, we already touched on that. I think it's mostly because tools are not adapted to this. And accidental property swaps, so if you have something like foo of ABCD, it can be tricky to remember the right order of parameters even if they are properly named. I think this mostly goes away with IntelliSense, or well, autocomplete, because IntelliSense is the Microsoft version of it, the Microsoft implementation. And I have autocomplete in Vim, so I can do that. And the second thing that I would say here is that maybe the problem is not so much with the function, but with the remembering the order of parameters, but mostly it's about the fact that you have 4 parameters or too many parameters for a function. And look at this, even if this is one reason why I picked this. So even if you look at this thing, if you see the names, reader, row, template, common values, writer, progress, display, that just works. Now, if the complete tools would be smart enough to actually look into this code and see, or look into the permissions that I'm defining and see, hey, you need here something that calls a render. So these are your options for something that calls a render from what you have has a render from what you have defined. Right? It's not so difficult to do. So I think this is mostly a non-issue unless all your 4 parameters have the same type, in which case the issue is moot. I mean, you'll still have to deal with the same problem. Now, the last answer that I got, and was very, very interesting, is from someone I don't know, but he gave me a very good answer. Finding problems at compile time rather than runtime, making invalid situations inexpressible. This is Barney Delar. And then my next question was, how far do you go with making invalid situations inexpressible? Because I know there is a certain style of programming in which you can write code. So let's say, for example, that you have a type and all values of that type can only have the values of 1, 5, and 10. Or maybe it's a month. So, and the values can only be 1 to 12 for January, February, March, and so on. Okay? There's a style of programming in which you can constrain this so that even if you try, once you define a month M, and you try to say M equals 13, this will give you not a runtime error, but a compile error. I first learned about this style of programming from Andrei Alexandrescu's book on C++. I think it's Modern C++ Programming, something like that, which is basically about metaprogramming. And it's about how to use the template system in C++ to enforce these types of rules. And when I first read it, it blew my mind. It was an incredibly interesting idea. Now, in case you don't know, there is actually a language that works with that. It's called Idris, a language for type-driven development. And here, basically, you have to define everything in types. So you can... Everything that you are building is a specific type, and that type has specific constraints. Now, I won't go more into Idris. The alternative to this, so this would be compile time checking with very strong types. This is something that I call very strong typing. It's something that you don't see often in programming. The alternative to this is what Barney talks about. I never tried Idris, but I love the ideas behind it. I like things like the builder pattern, where it guides you through stages. So you cannot do stage 2 before stage 1, because stage 2 is only available on the type return from stage 1. I've written a 3D geometry library when points in different spaces were actually different types, so you couldn't write code that didn't make sense. So the way this works is you define very specific types for very specific things. Like maybe you'd have... So here I'm not particularly certain what he means by points in different spaces. It can mean a number of things. But imagine that you have, in 3D space, you have 3 coordinates, and you have a x coordinate, y coordinate, z coordinate, and each point needs to have x coordinate, y coordinate, z coordinate. One way in which you could express this is to have point of 3 numbers. Could be floating numbers or anything you want to. Another way in which you could define this is to have point of coordinate or place on a coordinate. And you have a type that's a place on a coordinate, and you know it always starts from 0, it goes to infinity. Or maybe minus infinity to plus infinity, right? Depending on what you're trying to show. The third option is to actually make 3 different types. One that is coordinate x, second coordinate y, third is coordinate z. And all these types share the same constraints. They go from minus infinity to plus infinity. And the same structure, like they have one value, which is a float, let's say. But then in order to create a point, you might define a point builder that says point builder build on x coordinate, and then you get a point that has an x coordinate, and the type would be point with x coordinate or point on x axis, right? This is a specific type, and on that type you have the next method, which is build point on 2 coordinates, and you'd have dot build point on y coordinate, which will return you another type, which is point on x and y coordinate, and so on. You get the point. So not the perfect example, but just enough to give you something to consider. The advantage of this approach is that it allows you to specify, well, it reduces the number of mistakes that you can make when creating something like this. And okay, maybe for a point it's an overkill, particularly if it's in 3 coordinates. But then you might also have polar coordinates, you might also have imaginary coordinates, and so on. So maybe it makes sense if this gets more complicated. There are also some specific processes. If you think about business related stuff, maybe in some specific types you need to make sure that you are creating in a specific way and avoid some possible programming mistakes. So you cannot write code that doesn't make sense. And this is enforced by the type system at compile time, again, but it's not through metaprogramming. It's not through combining different parts of different classes or different parts of different types. And it cannot get as specific as you can only have values 1 to 12 unless you, well, you can, but you need to write quite a lot of code. If you want this to be validated at compile time, this is important. If you want it to be validated at runtime, that should be fairly easy. So this is a style of programming, and I think, as I'm saying, it works particularly well for domains that don't change a lot. Like geometry, if you write a 3D geometry library, most likely we won't have any fundamental new discoveries in geometry that you will cancel everything that you wrote in this library, right? So if you're doing something like geometry or physics, you're dealing with complex or complicated things, you want to make sure that you're not making mistakes when you're writing the code, and some of these things can get pretty complicated, then these styles of programming makes a lot of sense, and I would definitely use it there. But if what you are doing is the kind of application that changes at the edges, but you need to protect the edges, you need to validate your inputs and so on. That's very important. And then inside, what you want to do is to be able to play around with things, to add something new, like to add a new object that has a render thing and doesn't necessarily inherit from a complex hierarchy or something like that. Then this really works extremely well. So once again, it's not that you should only use style X or style Y of programming. No. What I'm saying is that I feel that many of the things that we think about when you think about type safety are not actually that important. And I think that this style of programming is something that I really enjoy, is something that pushes me to give better names to things and to actually think about names, because the only thing you have here are names. When you don't have the types, you need to think about the names that you are passing in. You also have tests, of course. And with this, you close in the loop and the possible issues here. And it allows a kind of freedom when programming, which is something I can't say about when I have to type for everything, like the type, and then realize, oh no, I don't, I need like a different type because this, I don't care, right? I just want to implement something that actually works. And to reduce the number of changes that I need to make to this method, this will probably stay like this for a very long time. Well, once I implement the thing that I'm trying to with this commented line. But once that is done, this will not change a lot. This will stay like this. What might change in this whole code is where we get the input, so more readers, well, where we write, so maybe more writers, something like that. But not the actual core. That will stay the same. And I think part of it is because of lacking the types here, not caring about the types. So now what I would really like from this is, this is another type of maybe a more subjective thing about this style of programming, is that I think we should stop trying to please the compilers. Instead, compilers should start helping us, supporting us. We have been writing a lot of code and adding a lot of extra stuff to please compilers and tools. Let's do it the other way around. I'm okay with giving more, a kind of permission system. I think that would be a great idea. I think it would be a great idea to have constraints, like if I'm defining a variable that is month, I would like to specify on that variable that it can only be of these values, 1 to 12, one interval 1 to 12, or January, or collection January to December of strings. And this should be something very easy to do. I should be able to say, I want a string, but I want from a string to only use concatenation and formatting, or only use formatting. I'd like to have more constraints on the general types, on the generic types offered by the system. And once I have that, I want to write those rules. I think they are important and they are specific for my code base. But once I do that, what I really want to have is tools that look at that and help me and say, oh, look, you need this you need this variable here because this variable is the one that has render function on it. Shouldn't be that hard, right? So this is my thinking about types, and I think this will go into much more, well, I hope at least this will take us into interesting conversations. Because I feel like a lot of people love types. I would really love to understand what's behind it. So really try to enumerate, what do you think types do for you? And which styles of typing are you using? Are you using the kind of Java types, Java or C#, where you have a type and then it's kind of validated at compile time and gives you some idea about what might be going wrong? Like if you're trying to call a different method that doesn't exist, or variables that don't exist, send parameters and so on with wrong types, sure, this is a possible issue that types can solve. Are you going further and having types check themselves a runtime? Are you going further and having types check themselves at compile time and kind of restrict everything? And in which domains do you think this works? So once again, I'm not saying that this is the only way of programming. I think we need different styles of programming for different types of problems. And the type of problems that we're dealing with in web applications or microservices are very different from the kind of problems we are dealing with when we talk about scientific libraries or something like that. If I were developing a scientific library, I would probably look at a type system like Haskell or Clojure or something like that. Something that I can use to constrain and to make sure that I have the right values and think a lot about the number, well, the values that are there and how they are constrained and so on. I would be very careful with that. But web applications, the thing that I care about is that the input is extremely well validated, that I don't get any bad input, either incorrect, invalid, or input that is actively trying to create security issues. So this would be at the entry, and that I'm saving the right things. What happens in between is something I don't care that much about in terms of constraints. And what I care about is to have these very small objects that I can move around and call and so on. What do you think about it? This should be an interesting conversation. And I hope this will be only the first part of this conversation. Thank you kindly for the view, and until next time, remember to think, design, and work smart.